Okay, now let's discuss the challenge of the C gate. So, as you can see, we have a circuit made of identity, which means numbers on the diagonal are 1, 1. If we place a single red gate, we'll get a minus. We'll get a phase flip here. But if we place a bunch of X gates, of course, they will just nullify each other. Nothing will happen, right? So you cannot get the phase. Remember, to get the phase, you need to make sure the qubit is in the one state first. So that's why if you sandwich the Z gate with X gates, you'll get what you need. And now for the second part. Same situation as we discussed. Simply by doing this, we should be able to both flip and pick up the phase. Doesn't matter which qubit gets one, but if both were to have a C gate on, then the thing would go blue. So we wouldn't want that. Of course, there's ways to make this less optimized, but yeah, this is the right answer for it. In the situation in which we want to get blue, remember, cancel the phase on the vertical. -1 will give you 1. The cases where it's 0, 1, 1, 0 will keep the red phase, of course, because one of them is active. For 0, 0, nothing will happen, and you'll get a solution. In the case of 3 qubits, same situation as on the single qubit, nothing really matters. We can place this here, here, or here. As long as we have a single combination, we'll get a solution. For this one, let's look at it, right? So we get -1 on 1, 1, 1, and we want to nullify this somehow. Where was our starting location? Let's find out. So our starting location was on 0, 1. So if we were to do this, we get the blue all the way to 1, 0, 1. So if we are to check it through this, we would get a phase, but we can nullify the phase and bring an X gate. So you can always think of the whole Hilbert space as a single space. And the moment you're able to do that, then small circuits like that don't really bring you an advantage if you look at the visuals. You can simply compute by just knowing what the gates do for simple cases. You'll see when the visuals become extremely powerful will be a lot later, and also to understand the actual operation of the gate. So now with 3 qubits, what matters is where we place the X gate. So if I do this, I will flip and I'll get 1, 0, 0 blue. But there is no way I can add another X gate here, right? So I will have to pick up this phase, which means I do need to nullify the case. So a very optimal way would be to solve this, would be to nullify the phase here, flip it, and then these two will bring it where it's supposed to go. If I were to place the X gates on top here, for example, right? Then what would happen is I would get a blue ball again, right? But if I do this, I'll get a red one. Yeah, but that's not what we want. But yeah, we could also try to cancel the phases, and by doing so, we should get another blue. So there's so many ways you can solve these puzzles, so many ways. Okay, now again, a very complicated looking thing. Blue needs to become red. All we need to know is blue needs to become red. So if we were to just do this, I think we got it right. And I think you can already see why. Yeah, I hope it makes sense. So we pick up the phase by pressing an X gate here, and then we cancel the directional change, and everything else was fine. All we had to do is pick up the phase, right? So we have the solution.